Okay, so homework 8.3, solving right triangles. We've done the definitions. Let's look at the questions. We'll do 2 on this sheet, and I'll change sheets of paper here. We have to do 4, 8, and 14. So number 4 asks us that if they give we need a cosine of some angle equals 0.8. And then it gives you a triangle. Should have drawn this ahead of time. Gives you a triangle, actually, goes the other way, where you have 8 inches, 10 inches, and 6 inches. So they're trying to ask you to figure out, okay, so which of these angles, is this angle A or is this angle A? And they're calling this angle 2 and this angle 1. They're saying which one is A if cosine of A is 0.8. Well, so the key is just to check your SOHCAHTOA, 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 SOHCAHTOA. Have you said that 60 times this morning yet? You need to. So, opposite sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. TOA, tangent, opposite over adjacent. So we're looking at cosine. Cosine is the adjacent over the hypotenuse. So which of these, from angle 2, if I do the adjacent over the hypotenuse, or for angle 1, if I do the adjacent over the hypotenuse, which one gives me 0.8? Well, you can see from angle 1, angle 1 would give me 6 over 10, which is 0.6. From angle 2, I would get, because 8 is adjacent to angle 2, 8 over 10. Which is 0.8. So angle A must be angle number 2. And so that's all you're doing with a problem like that. You're checking to see which angle, if you apply the ratio they've given you, gives you the ratio that they have asked for. And so angle 2 gives me 0.8 because it's this 8 over 10. So angle 2. Question number 8. It's a simple calculator practice. It says I need to calculate the inverse cosine of 1/3. And so that means my answer is going to be degrees. Whenever you use this, your answer, what you're looking for is you're finding an angle in degrees. Notice again, this is a ratio of 1 to 3. You could imagine this was a triangle where the adjacent side is 1 and the hypotenuse was 3. So it's a very easy problem. You just find your calculator. Make sure you're in scientific mode. Inverse cosine. I'm going to do 1 divided by 3, because that's the fraction 1/3. I'm going to close my parentheses, hit equals. So it is about 71 or 70.5. They say round to the nearest whole degree. So that rounds up to 71 degrees. So that's a very, once you know what you're doing, that's just a punch it in the calculator, make some money kind of question. Okay, notice again, inverse functions, take the ratio, you know the ratio, and then it gives you the angle in degrees. Okay, now comes the essential problem of this chapter, of this lesson, and that is solving for a triangle, which basically is the essence of, so this is number 14. Get our beautiful triangle drawn on here. Drawing off to the side of a tripod, so sorry, a little tricky. And solving a triangle means you're trying to find all sides and angles. They'll always give you 2 pieces of information. So look, they've given us the hypotenuse, they've given us 1 of the degrees, and when they say, this one says find all the other unknown measures. And what that means is by the end of this problem, I should know all 3 angles, and I should know all 3 sides. And I'm going to use trig and other things that we've already learned to do that. So it's kind of a longer problem, but you'll see the first couple steps are basic. So one way to kind of know you've done this right is you would set it up and go, okay, by the end of this, I should know what angle A is, I should know what angle B is, I should know what angle C is. And I should also know, I should know side A, I should know side B, and I should know side C. That means if you know all 6 of those, you have solved this triangle. And so I'll start with the angles because I already know the answer to that. Angle B is 90. Angle A is 32. And we already know how to find angle C. If they give you one of the angles, the other angle is very easy. These are complementary. 90, these must add up to 90. So this must be 90 minus 32. I'll just put the work here so remember that that's what we did. 90 minus 32, that is 58. Is that right, Joey? Okay, is that right? Let's see. 58, yes. Okay, so we have 58 degrees here. So now I'm halfway home. I got all three, and I'd write that in here. Keep that as a reference. I now know all three angles. So now I need my three sides. So I know my angles, and I need to solve my sides. This is where we use good old SOHCAHTOA, sine, cosine, and tangent. So you just pick. Which one do you want to find first? I need to find, this is side C, because notice it's across from angle C, just like this. This is side B, and this is side A. So that actually reminds me, we already know one of our sides. Side B is 7.4. All right, I only got two quantities to find, and I'm already done. Not so bad. Okay, so you just decide. I know what you do is you take the one you know and pick one to find. Eeny, meeny, miny, mo. A comes first, so we'll find this first. So that means I have a leg and a hypotenuse. So if I have SOHCAHTOA, chant it, SOHCAHTOA, SOHCAHTOA. So, okay, I have the hypotenuse. So I'm not going to use tangent because I don't know either of these. So I'll just pick the one that makes you happy. It also kind of depends. Well, we'll just pick an angle. I like 32. So if I'm at angle 32, A is opposite of 32 and hypotenuse. Opposite hypotenuse from 32. I could have done 58. I'd pick 32 because it's smaller and it made me happy. 32 is opposite over hypotenuse. So that means I'm going to use sine. So that's kind of the trickiest step. You got to make sure you set things up correctly. Sine of 32 equals opposite over hypotenuse. And this is what we did yesterday on 8.2. Now I just need to solve for A. I'm going to multiply both sides by 7.4. So that 7.4 times sine 32 is going to give me side A. So let's take our handy dandy Samsung Galaxy. Okay, sorry Apple friends, but you're inferior. All right, not going to do inverse sine because notice I already know my angle, so I'm not using inverse sine in this problem. I'm going to shift back and just use regular sine. Sine of 32, I can close parentheses if I want to do this all in one step, times 7.4. So that side is, let me see if we're supposed to round it to the nearest hundredth. So 3.92. 3.92. So A equals 3.92. Nice. That's exciting. Given that this is 7, that seems like a reasonable answer. Let me just glance in. Yep, that is correct. 3.92. So now all I have to do is to find side C. Just FYI, if you love the Pythagorean theorem, a squared plus b squared equals c squared, I could do that right now to find C, but I like trig more. So I'm going to set up another trig ratio. Again, I like 32. I'm going to stick with 32. It's my favorite. So 32, I need to think what ratio would allow me to solve for C. Now that I know both of these, I have options. I could do tangent of 32 is 3.92 opposite over adjacent, or I can do cosine of 32, which is adjacent over hypotenuse. So I can do either one of those. Let's go ahead and use tangent, because poor tangent sometimes I think gets left out. All right, so tangent of 32 equals TOA, opposite over adjacent. So the opposite is 3.92 over C. Okay, FYI, I think technically I think cosine would have been a little easier because sometimes this step confuses people when you have the variable on the bottom, but I'm doing that on purpose so I can remind you how to do it. So I need to solve for C. Again, as a work we did yesterday, I showed you that what's basically happening here is I'm going to multiply both sides by C. So I'm going to get C times this equals 3.92, and then I'm going to divide by tangent of 32. I'll just do it. I'll go ahead and just do it. You can do this much faster, but I'm showing you why it works. times c, so c cancels out, and so then we get c times tangent of 32 equals 3.92. So c times this equals that. How do I undo this? Divide by tangent 32. So c is equal to 3.92 over tangent 32. And so we can go ahead and calculate that. Notice again, I know my degree, so I'm not using, ironically, even though this is the lesson is on inverse functions, or at least you're going to use it a lot, I'm not going to use the inverse function to solve this. So 3.92 divided by tangent of 32 degrees. I'm going to close my parentheses. 6.27. 6.27. Very good. The book says, well done. C equals, it's approximate, notice. I should put approximately here. Yeah, it's not exact. 6.27. 6.27. If I'm labeling everything, 6.27. Oh, and I want Mr. Mefford to mark down my notebook. So let me make sure I box, or I could just do this. Box my answers. Okay, and so now we have solved a triangle because we found all three angles, which you notice that I didn't even have to use trig to do that, and I found all three sides. I already knew one side. I had to set up two trig ratios to solve for those. Just a quick FYI, I don't want to make this too long, but I had options. I used sine of 32 because I said I liked 32. When I was trying to solve for a, I could have used 58. And then I would have used cosine, if you can see, because I knew the hypotenuse and a to 58 was adjacent. So I could have just as easily to this problem done something like this. Cosine of 58 equals a over 7.4. This is an alternative reality. I could have done, I could have done this if I decided I wanted to use 58. The key is pick an angle and then make sure you just set up the right SOHCAHTOA ratio using the variable that you're trying to find. All right, I won't give another alternate reality and blow anyone's mind. But just rather, there's many more than one way of ratios to solve these. But just pick one and make sure you're honoring SOHCAHTOA accurately, and you shall be fine.